Another week, which means another lesson of maths. Today, we are going to be covering grade 11 maths, the topic of trigonometry. We're going to go through a couple of simple proofs, a couple of worked examples, just touching on trigonometry. I assume you know the basics, so we're going to take it up a level. Let's get started. So the first example we're starting off with is a simple simplification of a trigonometric expression, which is the square root of 1 minus sine theta, cos theta, tan theta. And the first trick that you look at when you look at this expression is, well, my simple basics that I know about trigonometry is that sine theta over cos theta equals tan theta. So I've got that. I also know that sine squared theta plus cos squared theta equals 1. So if I look at this expression and knowing those two trig identities, what would be the first step that I'm going to use? I can see that tan theta is over here. So if I had to use the result of tan theta being equal to sine theta over cos theta, if I substitute this back into there for the next line of this simplification, I'm going to have the square root of 1 minus sine theta cos theta and sine theta over cos theta. So I've substituted that back in for tan theta. And now I can see that this numerator and this denominator, there's a possibility of cos theta being able to cancel each other out. So next step would be 1 minus sine theta, and that can cancel with that. So the cos thetas are eliminated from the expression. So you'd have sine theta multiplied by sine theta. So looking at this resultant expression, this will give you sine squared theta. And this whole expression now looks like a trig identity that you know, which is sine squared theta plus cos squared theta equals 1. You could write this expression now as the square root of 1 minus sine squared theta, which is equal to the square root of 1, which is equal to cos squared theta. Therefore, it is equal to cos theta. And that is the result of your first simplification of a trigonometric expression using these simple trig identities. So, our next example is a simple proof that involves trigonometric expressions, where you'd want to prove that the left-hand side, which is the left-hand side, is equal to the right-hand side. So usually you get this in a lot of tests and a lot of exams that you get, where your teacher would ask that you prove that the left-hand side of the equation is equal to the right-hand side of the equation. So this involves taking either side and trying to simplify it to replicate the other side of your equation. So let's do it on this one, taking the left-hand side and trying to get it to be equal to the right-hand side. I've seen a lot of the kids that I work with struggle with understanding the left-hand side and the right-hand side of the equation. So we're going to take this left-hand side and write it as left-hand side equals this, which is 1 minus cos theta over sine theta. 1 minus cos theta over sine theta. So looking at this expression, we know that we would want something of the form of the right-hand side. But you already know, evaluating the numerator, that 1 minus cos theta kind of gives you the flavor that you're probably going to use the trig identity, or the difference of two squares of 1 minus cos squared theta. So what you're going to do with the left-hand side here is you're going to multiply it by 1, which would be timesing it by 1 plus cos theta over 1 plus cos theta. Because remember, 1 plus cos theta over 1 plus cos theta is 1, which is the same as 10 over 10, which is the same as theta over theta. You are just multiplying this term by 1. So you're not actually adding anything or minus anything, you're just multiplying by 1. So what would the result be for multiplying this? Well, you know that is the difference of two squares. So you're going to have 1 times 1, which is going to give you 1. 1 times cos theta, which is going to give you cos theta. You're going to have minus cos theta times 1. So you're going to have 1 minus cos theta, and negative cos theta times cos theta is negative cos squared theta. Right? And divided by, what is in your denominator? Which would now be the product of these two terms. So, sine theta times 1 plus cos theta should be equal to, what's the numerator? 1 minus cos squared theta over sine theta 1 plus cos theta. And that over there is equivalent to the trig identity that you know. Cos squared theta plus sine squared theta equals 1. So this would be equivalent to sine squared theta. Substituting that trig identity that you know, you've got sine squared theta over sine theta bracket 1 plus cos theta. Now, it looks like there's two terms that you can cancel. So you can cancel 1 sine theta with the one in the denominator, and the result would now be sine theta over 1 plus cos theta, which is equivalent to the right-hand side of your equation. So now you've proved that it is equal to the right-hand side, and the left-hand side is equal to the right-hand side, which is the whole reason why you went through this derivation. So, good job.